What up? So, recently I built a printer with the Mrs. ET department, a clone of Prusa to be exact. It was first proposed by Tom, you'll find a link in the description. So let's print something. And first we have to make a model, right? We'll use open software, you can install it right now and follow along. We'll make a flat model from picture. You can pick something like a symbol, logo or a cartoon character. Something with a few colors and distinct borders. I'll use Marcus Aurelius as a object. So you've chosen a picture. Fire up Inkscape, a vector graphics editor, open and free, all soft here is like that. Run Inkscape and open your picture. It'll show you the import dialog. Leave all the top options here. First one is the import type, whether to copy the image into Inkscape file or to link to an external one. Second one is import resolution. You can use a native picture resolution or Inkscape standard. Third is the render mode. You can choose to have visual smoothing, disable it, or let the machine decide. Then click the right mouse button and choose Trace Bitmap. So what does it do? There are two ways basically of describing a picture. You can present it as a table of equal rectangles or pixels and specify the color of each pixel. Or you could describe it as a group of unique paths and specify the color inside each path. If you want to see a black circle, you can build it as an approximation from black and white squares, pixels, or specify literally that it's a black circle, or a curve in the shape of a circle. All that is called raster graphics in pixels case and vector graphics in paths case. And trace bitmap is the function to build a group of paths based on a table picture. In this window we can see the tracing parameters. We need multiple paths to create an interesting surface, so let's look at the bottom half of the options. Next, the main difference between outlines is color, so pick that one. Scan specifies the numbers of resulting paths. It might seem that if you want to get 3 paths or 3 height levels, you need 3 scans. In practice, part of the colors that it picks are not the ones we want, and you won't lose anything if you apply stacking and scan more contours than you'll use. You can just delete the excess ones. Here I looked at the forehead wrinkles. With minimal number of scans, made them not be green. After tracing, we get 8 layers on top of one another. The bottom one is a white rectangle. I'll use this shape as a print base. We don't care about the colors here, shape is what we need. We'll select the best contours in the next software gem. For now, let's save it. Inkscape will try to do it in your original raster picture format. We need to do it into SVG or Scalable Vector Graphics. After that, close Inkscape and open Blender. First it'll ask what preset you need, select General. Then delete the starting cube, we don't need it. We need to import the SVG we made. Go into File, Import, select SVG. Be careful not to select SVG as grease pencil. By listing true contours in the tree, you can delete the unnecessary ones. I left only 3. Base rectangle, main shape and fine details layer. Then we need to convert these shapes. Right now these are curves. Each node supports only 2 connections in each direction with other nodes. It allows to connect them with smooth curved lines, but doesn't allow the construction of 3D shapes. For each layer, click on it with right mouse button and select Convert to Mesh. Mesh doesn't support smooth connection between nodes or vertices in Blender, but you are not restricted in the number of connections each node supports, which is necessary for 3D shape construction. Then select a Now Mesh and press Tab. It'll take you from the composition mode, where you arrange multiple objects, to the selected object editing mode. Here press A to select all vertices and E to extrude them. Extrusion creates a copy of selected nodes and relations between them, connects corresponding nodes, and by default moves it in direction perpendicular to the average plane of selection. Put simply, this operation will turn circle into a cylinder, square into a cube, civic slot into a hexagonal prism, and so on. Extrude the white rectangle down a little. After pressing E, you just need to move the mouse into desired positions and click left mouse button. Don't forget about Ctrl Z if anything goes wrong. Exit edit mode with Tab and repeat for the remaining 2 meshes. I think I'll make a lantern, therefore my base layer is thinner than others. You might have a different situation. Also, here main shape and detail meshes overlap, but that's fine. Now you can export, but it'd be nice to do one more step. Drop a modifier on top. Selecting each mesh once again, go into a tab with a little blue wrench, the Modifiers tab. Modifiers are basically filters for a model, and you can apply it permanently by changing the model itself or use them as independent filters. If so, a model will remain the same and you'll be able to change options and turn off the modifier at will, at a cost of additional computing power needed. Let's select the Triangulate modifier. It separates any non-triangle in the model into triangles. The thing is, for Blender, models made of quadrangles are most natural. The format into which we will export the model, however, likes triangles. You can actually make models out of any number of angles, so if you someday need to cut down on the number of angles in the whole model, use this modifier. Label options set standard values. Minimum vertices at 4 means that it will separate into triangles anything with 4 corners or more. Repeat for all meshes, then go File, Export, STL. This is a simple, old and universal format for 3D models. During export you can notice Apply Modifiers checked on the side. It means that it'll pass the mesh through the modifiers and export the result of it. The model is ready, but it'd be nice to check if everything is alright, so let's open Prusa Slicer. I will, you might enjoy something else. Here we don't care about optimal print options yet, we just want to check if the model is readable and is interpreted correctly. So let's open it, resize it so it fits onto the build plate and press Slice. And everything works, all the contours are drawn, there are no weird cavities, use the slider on the right to travel between layers, and knowing that this process works, you can now jump between the initial picture, SVG file, model and physical print in order to achieve something cool. We'll print in the next week. For now, as a YouTube custom, don't forget about likes, dislikes, subscribing, comments. Use comments to ask questions if something is unclear, and I'll see you in the next one.